5-6, we left off in the middle of example 1. If we review real quick, based on sides A and B and angle C, we found side C, right? And then, based on, at that point, knowing side C, we have to find either angle A or angle B. Why are we starting finding angle B? Okay, angle A is going to be, or at least bigger, very possibly obtuse. We don't officially know that yet, but there's a chance angle A is going to be our biggest angle, so it might be obtuse. Remember what I said yesterday? We need to find the smallest angle first. Okay, don't take the risk of otherwise. So if I start filling in my information, b squared 5 squared equals 11 squared plus 6.5 squared minus 2 times 11 times 6.5 times cosine of b. This is the one where the solving is going to be a little bit more involved, so make sure you know your steps. Because in all honesty, the first one we did, you could pretty much just enter that in the calculator from the beginning. Okay? On this one, we have to be careful with our steps. So 5 squared is 25, 11 squared is 121, 6.5 squared. 42.25, he says. Okay. Minus 2 times 11 times 6.5? 143. 143 times cosine of b. Okay. Now, what can we do?
Subtract 25 over. Oh no, can't do that. No.
We could, but I wouldn't want to.
You can
Add those together.
add like terms. That's
Okay. So one thing we can do is add the like terms of 121 and 42.25. So I still have 25 equals. 121 plus 42.25 is 163.25. Still minus 143 times cosine b. What are we solving for?
B.
B.
Big B.
Okay, so we're solving for big B, which means we're solving for cosine B. So, when we solve for B, we're working to get B by itself, right? So right now we're working to get cosine B by itself. So subtract the 163.25 over to the left, because my job is to work to get that B by itself eventually. So what is 125 minus 163.25? Okay, negative 138.25, and that's going to equal negative 143 cosine b. What's my next step in getting b by itself? Okay, so we're working to get cosine b by itself. So we're going to divide by negative 143. Okay, and I'll do that in a separate step. Now, what I'm guessing is that when we do the negative 138 divided by negative 143, I'm kind of guessing it's going to come up a not fun decimal. Yeah. And so what I tend to do at this point is I tend to just write it as a fraction. And I'll put it into my calculator as that fraction here in a little bit. Okay, I would not suggest getting that decimal and rounding it. If you're going to go ahead and get the decimal, make sure you use that big full decimal later when you do the problem. So I'm going to write this as cosine b is going to be equal to, what is a negative divided by a negative?
Positive.
Can I go ahead and say positive at least? Mm-hmm. Positive 138.25 divided by 143. How do I find b? Someone already said it. We're going to do the inverse, right? If it's cosine b and I want to know what b is, we're going to do the inverse. So b is going to be the cosine inverse of 138.25 over 143. And that's where if you already got the decimal, use that big full decimal in your problem. Okay? What are we getting as an answer?
I'm right. It's 14.8.
Okay. So then we know, and this is angle B, right?
Oh my god.
Is 14.8 degrees.
No.
Did we hit a wrong button?
This is the best thing that's happening all day. It is 14.8. Today's a good day. Shoot.
Only because you proved Mario wrong?
Yep.
Okay.
Well, he does it to me all the time. I should at least get it to him.
Okay, guys. We have side C.
See, but I think they find this thing.
We have angle B. What else do we have to find?
Okay. Angle A.
And how are we going to find angle A?
14.8 plus 8 plus 20. And subtract that answer. Well, 180 minus 8. Plus 8? Where's the plus 8 come in?
I think she
I
misspoke.
said plus 14.8.
I think she's on the first floor.
You said an extra 8 in there that confused us.
Oops.
Okay, so the idea of all three angles in a triangle add to be 180. This is why we save that biggest angle for last, because if it's obtuse, we're just subtracting from 180. We're going to get that obtuse angle we're supposed to. So angle A plus angle B plus angle C equals 180 degrees. Angle A is what I'm still finding. Angle B was 14.8. Angle C was provided as 20. And what'd you guys say angle 8 was?
What? 145.2. Oh.
145.2. Okay. You can try it on your own sometime if you want, but if we, back here in my purple step, had tried to find A, we would have not gotten this 145.2. Okay? We would have gotten some acute angle. Because when you put this cosine of a value in here, we would have gotten an acute angle. Or you would have gotten an error and it would have just not worked for some reason. Which is possible too. Okay? Questions there? Okay. You've kind of seen both solving options. Okay? If you're just solving for, you're either going to be solving for the front variable. So like in this case over here, side C. So whatever that front squared is. Or you're going to be solving for the angle. Those are pretty much your two options. You're never going to be solving for those two pieces in there. That's when we're going to use one of the other equations. Okay? Okay. Let's try next one. Example 2 takes us to solving a couple of angles that are side, side, side. Okay? So, as we look at this one, we're going to be asked to solve triangle ABC, given that A is 7.7, B is 4.5, and C is 19.5.
Find angle B first.
Okay, why would you suggest finding angle B first?
Smallest side, smallest angle.
Okay, smallest side, find the smallest angle first. Now, I have a hint to you. In a side, side, side situation, there's a small rule you should always check first to save yourself some time. We mentioned it yesterday, but I know that was a whole 24 hours ago. And that rule that I'm going to suggest we check
They are not bigger.
remember, two sides, the two smaller sides of the triangle must add to be larger than the third side, or it physically cannot create a triangle. What do we notice about our three sides?
Doesn't work. There's no work.
Yeah. The idea that A plus B, because they're the two smaller sides, needs to be greater than C. So 7.7 plus 4.5 needs to be greater than 19.5.
Ain't gonna happen.
And this is it 12.2?
Yeah.
I did mental math. Always a scary thought. Especially on Friday, right?
Yeah.
Okay. Is 12.2 greater than 19.5?
No.
No, it's not. So, this falls into your favorite category in a way because you don't have to do the math. If you catch this, it's not a triangle.
I was ready to do it anyways.
Now, there is a chance, and I'm not 100% sure exactly, if you try and work this out, that you would run into an issue and get some kind of error.
Error.
But just because you get an error does not mean that's a mistake that was made. Okay? So just kind of be aware of that. So not a triangle. I'm going to write myself a note that, why was this not a triangle? Two smaller sides must add to be, I want to say, larger than the third side, or larger than the longest side, largest side. I don't know a good way to say that, but okay. I'm ready for B when you guys are. Another side example. Solve triangle ABC given that A is 9, B is 7, and C is 5.
This one passes
Oh, you're not going to let that happen again?
with flying colors.
You're going to double check. So I would, two smallest sides, 5 plus 7, that is greater than 9. Okay, it passes. And that's a real quick, easy check to do, right? You didn't even have to write anything down or grab a calculator for this one. So, okay, what do you want to start off doing?
Probably find an angle C.
Finding C is also.
I'm finding angle C first, because that is going to be, it's the smallest side, so it's going to have the smallest angle opposite it. And this is just in case we end up with an obtuse angle at the end. So if I'm going to find angle C, which equation am I using?
C squared.
The one that starts C squared. C squared equals A squared plus B squared minus 2AB cosine of C. Do some math. I guess we have to fill it in, then we'll do some math. 5 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of C. Once you're filling it in, you're okay with the math, right? I'm going to keep going here. 25 equals 81 plus 49 minus 126 cosine of C. You can take individual steps. You can do a couple of steps at once if you want. I'm going to take it step by step here in that I can add 81 and 49
130.
and get 130 minus 126 cosine C. Can I subtract those two? Why am I not subtracting 130 minus 126?
96.
Yeah, 126 is attached to the cosine C. So instead, what am I going to do? Okay, we're going to subtract the 130 over. 25 minus 130 is going to be, darn it. Okay. Negative 105 equals negative 126 cosine of C. What do I do now? Yeah, to get the C, we're going to divide the 126 over. Now, I'm going to say a negative divided by a negative is a positive, and I'm going to write this as 105 over 126. I hesitate to say always, but there's a portion of me that wants to say you'll always end up having a negative divided by a negative there. Okay, I don't really see how you wouldn't because it's a negative cosine value over here. So I believe you'll always have a negative divided by a negative. If you don't, you might double check before you go any farther. Okay, how do I actually find C?
Cosine inverse.
C is going to be cosine inverse of 105 over 126. You guys all got the calculators working, right?
Yeah.
33.6? Are we all agreeing? Okay, agrees with my notes. What's next?
Angle B.
Angle B, because
It's the next.
it's the next smallest, right? Or next largest, I don't know which way you say that, but it's not the largest one, right? Okay, so we're going to start with angle B, or go to angle B now. That means I'm using which equation? Okay, the one starting with B squared. Uh-huh. B squared equals A squared plus C squared minus 2AC cosine C. Gosh darn it. I agree. Cosine B. Thank you. I would have been really confused later. Probably would have realized it when I was filling it in, though. Hopefully. 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of B. 49 equals 81 plus 25 minus 90 cosine B. And go ahead and add my 81 and 25. Get 106. Still minus 90 cosine B. And then to solve for cosine B, I'm going to subtract that 106 over. 49 minus 106 is what? Oh, negative 57, is that what you said?
Yeah.
Okay. Makes sense once I heard it, right? 106 is canceled, so negative 57 equals negative 90 cosine B. Notice it's a negative and a negative, yes? To get cosine B by itself, I'm going to divide the 90 away. So negative 57 divided by negative 90, which you're always going to see me go ahead and write that as a positive divided by a positive then. And in order to find B, we're going to do cosine inverse. And you're practicing these on the calculator, right? So then angle B works out to be 50.7 degrees. And what else do I need to find? Angle A. How am I going to find angle A?
Add both sides.
All three angles equal 180, right? Could I use law of cosines here?
Yeah.
No.
Oh.
If I use law of cosines here, it would be the same thing as using law of cosines right up here in the beginning to find A.
So you.
Because you'd still be using A, B, and C, and you'd still be using that same data. Until you put another angle to it for reference, it's not going to work. So you cannot use law of cosines to find, if it's obtuse, that is. If it's acute, you could. But B and C are not over 90, so it's going to be obtuse. So, angle A plus angle B plus angle C equals 180. So we end up with the fact that angle A is what? 95.7. Okay. You've seen some examples, yes? You know what you're doing. Okay. Shall we talk some baseball?
No.
Maybe softball.
This could apply to
You have
softball.
softball special, right?
I do.
Same thing.
It's softball day for me.
Today's middle school's first game.
We have a game tonight. Yeah.
Zeke's going to watch. Zeke has a girlfriend? Kind of. Ish.
I know.
Zeke!
It's not really a girlfriend, but like they've been
Serenity
talking
plays-
for a really long time.
Is Serenity the real tall, skinny looking one?
Yeah.
She's
So
just a girl. Zeke.
And Zeke's also a real
Okay.
one.
The bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. Okay? So, as we think about this, okay, okay, let's see what I can draw here. Okay, there's my baseball diamond. Kind of, right?
Yeah.
We're going to go with it. Let's see. We're talking about home plate and first base, right?
Yes.
So home plate. There's my home plate. We have first base over here. Okay. The bases on a baseball diamond are 90 feet apart. So the distance between home and first is 90 feet, or at least on this particular baseball field, right? Front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. So, pitcher's mound somewhere in here. Okay. And the distance they're giving is that the front edge of the pitcher's mound and the back corner of home plate. So that distance right there is 60.5 feet. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. Okay. That's what we got.
I think that looks great.
It's not half bad. I'll take it. I've done a lot worse. So, I'll take it. Thoughts?
Would that be A, B, or C?
We can make them whatever we want.
Well, I think 90 has to be
C.
C. doesn't it?
Say what?
90 has to be A. No, A is the biggest.
Well, wouldn't that be a right angle?
Well, we can, okay, so
it's
we
not
can
downstairs.
label A, B, and C however we want. There's nothing that says how we have to label A, B, and C.
Oh.
Okay? I mean, if I look in my notes, I don't know that it matters. I have it labeled as A, B, C, which in that case makes it what?
B.
B is 90 feet, C is 60.5 feet, and we're trying to find A. Now, in all honesty, it doesn't matter about the ABCs. Okay? In order to find that, we're going to have to know a little bit more information.
Do we need to find A? Well,
And so we're going to have to know some kind of angle in here, aren't we?
wouldn't angle B be 90? That way I guess we don't really need to know.
Angle B would only be 90 if it was on a straight line between first and third.
But in theory, it should be a straight line.
But it's not necessarily. What age group are we talking here? Where is the pitcher's mound? Okay?
But even
But here's in our scenario here, we don't know that that's 90 degrees. And in fact, it's not. If it was 90 degrees, this would have been back in chapter 4 when we were doing SOHCAHTOA. Okay? So,
who has your classes?
so if B is not 90 degrees, come on, focus. What do we maybe know? We don't know B. There is an angle we know. But it's not B.
Do we know that one? We know A
How could we know A?
because it's just half
Okay.
90.
The first baseline and the third baseline coming into home plate form a 90 degree angle. The pitcher mound is where from home plate? Straight out. So that means that, yes, we can assume 45 degrees, and that doesn't matter what age, what level we're talking about here. Okay? Do we have some information we could work with here? Yeah. we know this is if you will, a side angle side scenario. So guess what law can apply? Law of cosines. If we're trying to find A, we're going to use the equation that starts with A. So A squared equals B squared plus C squared minus 2BC cosine of A. Do some math. I'll plug some numbers in. A squared equals 90 squared, not 90 degrees, plus C squared, 60.5 squared, minus 2 times 90 times 60.5 times cosine of 45 degrees. Now, if you wanted to, you technically could plug into the calculator right now. I don't know if that makes sense or not. You could technically plug this whole thing into the calculator as one big, we have fancy calculators, right? As one big thing. 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine of 45 degrees.
Just it.
And get that value. And then what are you going to have to do to that value?
Square root.
Square root it.
She was like, this answer.
This answer is huge. So if you plug that all into the calculator and you don't show all these other steps, and here's the idea. You still need to know how to do all those steps, right? Because there are times it's important. But I'm also trying to save time here. So before you take the square root, you get a 4,000 number, right?
4,059.8.
Once you take the square root, we're at
63.7.
63.7 what?
Feet.
Feet. Is that a reasonable answer?
Yes.
Right? Obviously, if you stopped at the 4,000 number, I would like to think you would realize, like Sophie, whoa, what? We can't be done. Okay? So definitely be reasonable. Make sure it's
So
reasonable.
what age group was this model?
Not a clue. Not a clue. I'll be honest. Okay, so I'm trying to think. What if I watch Logan do? Is there pitching mound on a direct line between first and third?
Our pitching mound is, Pixie is, I don't know about the team.
Now I'm trying to think.
I know. I don't know.
Baseball is.
All I know is you can't assume that because there's a lot of depends on age groups and stuff. So, okay, we have two other formulas to get to. Okay, these are two other little kind of side formulas, pretty basic, just kind of understanding them. This first formula we're going to look at is a formula to help us find the area of a triangle. Okay. Now, it's listed as area equals 1/2 times A times B times sine of C. And this is going to be provided it is a side angle side that you are given. Okay. Now, realize this capital A here stands for what? That is area. Okay, that's not angle A, that is capital A as in area. Now, this is 1/2, basically what's saying it's 1/2 times the side, times the side, times the sine of the angle between them. Excuse me. This could also be written out with the other variables. So if you want to, you could also say area is instead 1/2, instead of using AB, we could say BC, and then B times the sine of angle A. Excuse me. You could also write the formula as 1/2 times, what combo have I not done? AC, and that'd be times the sine of angle B. Sorry. Now, let's look at how this is going to help us find the area of this regular octagon, inscribed in a circle of radius 9 inches. What's an octagon?
8 sides.
8 sides, right? And what's it mean if the octagon is inscribed in a circle? It's in a circle, and every point of that octagon is touching the circle. Trying to remember which way I draw this better. I think I do better if I draw the circle and then I try and put the octagon in. Now, my brain for an octagon, I don't know if this is going to work or not,
Do 2 squares.
does,
I can barely draw. So.
I know. So I'm
You
really having an issue
Okay.
now.
You do a square.
my octagon, I think of a flat side, top, bottom, left, and right,
Oh yes.
and then I angle the corners.
This is an actual circle. Look at the circle. I'm proud of this.
I draw 2 squares, and then like one is
Yeah.
there, and then one is 90 degrees.
Yeah.
Or 45.
My circle.
We're going to go with it.
Oh, that's
I got something. Mine's a little lopsided, so it's a little goofy on one side, but you get the idea.
I'm gonna curve mine.
Now, we know this circle has a radius of 9.
Oh, that's heavy.
Now, a radius of 9 goes from the center to the edge of the circle. Well, I'm going to pick to draw my radius to the edge of the circle where it's also the corner of the octagon. Now, that's one radius. I can also draw another radius. Another radius. Do you see what's happening here?
Oh my god.
I don't.
Come on, focus here. I'm going to run out of time if we don't focus. You've got to stay on task with me. I just drew in all 8 radiuses, or radii. What did I just create?
A bunch of triangles.
A bunch of triangles. Officially, what do we know about those triangles? I know my picture doesn't show it, but what do you know about the triangles?
They should all be identical.
They should all be congruent. They're all identical, yes?
Yeah.
And I know that because this was what type of octagon? It's a regular octagon.
Thank you.
Do you remember what it means to be a regular polygon? All sides are equal, all angles are equal. So this is a regular octagon. This is a regular stop sign, if you will. Okay? So what we can look at is that if this radius is 9 inches, and this radius is 9 inches, okay? In order to use this area formula, I need a side angle side setup. Which means I need to know an angle.
If they're all congruent, shouldn't all the angles be the same?
All 8 triangles are congruent, so all 8 angles, central angles, should be the same.
45.
And why 45?
Because 360 divided by 8.
Okay. It's a full circle, so that's 360 degrees divided into 8 pieces. So this is going to be 45 degrees. And that was because, I'm going to write it up here, 360 divided by 8 is 45 degrees. For when you look back at this later and say, what? How did we get 45? Okay. How can I find this area?
Plug it all in.
Plug it all in. So my formula is 1/2 times side times the sine of the angle between them. Do we have that information? Yeah. So I can do 1/2 times 9 times 9 times the sine of 45 degrees. And there's a catch. What else do we have to do? What is that finding the area of?
The
Okay.
circle, the triangle.
This is the area of one triangle. What are we asked to find?
Oh.
The octagon. How do you find the area of the octagon?
Multiply by 8.
Multiply by 8.
Multiply that whole answer by 8. I do have the area as 229. 229 what?
Inches.
Inches.
Inches square. It's area. I just have it 229 in my notes, so I don't know what it was originally, but
I got
At least I got the 14.
okay. Are we good here?
14.8.
Okay, be aware of this. You could be asked to find the area of just a single triangle or the area of a whole shape, yes? So you have to pick and choose depending on what you need. That is an area of a triangle formula. We're also going to look at something called Heron's formula. Okay? Heron's formula is a formula that's going to find the area of a triangle. So it's another area of the triangle formula, but it's going to be based on the sides. So this is going to be based on a side setup. Okay? This other formula was based on side angle side. This one is based on side. So if we know all three sides of a triangle, we can find the area. Now, A, B, and C obviously represent the sides, right? And then the other thing you're going to see in this formula is you're going to see S. And S is what is called the semi-perimeter, aka half of the perimeter. And so they give us a formula for S here, that S is A plus B plus C divided by 2. Okay, let's use it. Find the area of a triangle with sides 13, 15, and 18. Well, it says find the area, yes. What are 13, 15, and 18 in my formula?
A, B, and C.
Those are my ABCs.
That should be.
Before you find your before you set up your formula, you should also probably find your S. How do we find S?
A plus B plus C divided by 2.
A plus B plus C divided by 2. So 13 plus 15 plus 18 divided by 2, and it's what?
23.
It's 23. Okay. Set up your formula now. We're trying to find area, so I'm going to use capital A equals big old square root
That's a big square root.
S, which is 23, times, in parentheses, S minus A. So 23 minus 13 times S minus B, so 23 minus 15, times S minus C, so 23 minus 18. Plug it all in your calculator or do a little basic math before that. If I clean this up a little bit, it's 23 times 10 times 8 times 5 under the square root. Not that you even have to do that. Square root of all those numbers multiplied together is?
95.
Yep. Okay, I have 96 written down in my notes, so 96 what?
Something squared.
Something squared. If they don't give us a something,
Isn't it just units?
units squared. Okay,
I forgot about that.
what?
The units.
Units, yeah. Okay, guys, your homework is on page what?
440 page.
440.
2 through 28 units and 31 to 32.
2 through 28 evens, 31, and 32. And we're done with this chapter.
I should just start putting the word units on my physics tests.